go.
So on last week's homework, was everybody okay with that?
Mm-hmm. Yeah.
Sorry about that. I decided I'm going to stay at my work on Tuesday nights and Thursdays and do my homework here, so I don't get kicked off again.
That's okay. I feel like we've had a super good group, and it just kind of flopped last Thursday, and that happened. So.
And I was trying to get on so hard.
Yeah.
Well, we only had cheerleading last week, so I'm done with cheerleading for a while. So
cool.
We're good.
All right. So who wants to start with our group quiz? What we got for those?
So okay, wait a second here.
I did not get all the way through my group quiz yet. Just because my husband's been out of town and I've had 2 sick kids. So I have not done it yet. I was starting as we got ready to start. I just haven't gotten through everything. So
okay.
I just saw that you guys were going to do it that way, so I didn't even get.
Okay, so should we just?
Working on it.
Okay. Do we want to just work through it like normal then, and then on Thursday we'll make sure we have it done?
Yep. Yeah, that sounds good.
On number 3, I got 16.45. Did anybody get that too?
I got 36.895. Oh, you're doing the margin of error, right?
So the margin of error equals the 1.645 times 50 divided by the square root of 25.
That's what I did, and I got 16.45.
Because all they want to do is know the margin of error. They don't want to
I think I did some.
So the formula for that was m equals and whatever the z value was.
It was 1.65 times 50 over the square root of 5.
Correct.
Okay, then I must have just done that.
All right, that's what I got a 16.14. 16.45 also.
Okay. All right, and then number 4, which of the following statements is true? I had that the sample mean is a point estimator of the mean.
So the x bar of u, of the population mean.
Yeah, that's it's a point estimator of mu. Is that right?
That's what I have. That's what I thought.
Number 3.
Yeah.
Cool. Okay.
Okay, so Gina wants to construct a 95% confidence interval for GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of size 64 and computes x equals 526. Use this information for questions 5 through 8. So then we just set that up in your normal, not your normal, sorry.
Confidence interval formula?
Yeah, that one.
And so when you subtract it, I got 498.315.
Okay, I'm going to set it up first because I need to write it out or I'm going to just be totally lost.
Okay.
Because if I don't, then I'll look back at it and go, okay, how do we get that answer?
Okay. So it's just the 526 minus our...
So for the lower value, did you get the 498?
Oh, you know what? 498 but see, I'm not sure because if I...
That's for the minus, that's for the low.
Yeah,
so what I'm doing is
498.315.
Yeah, so you take the 1.96.
Okay, I just lost what you guys said there.
So 27.6.
Courtney, will you say again how you set that up? Like,
yeah. So for the lower limit, it's just the x bar minus mu, which is the margin of error, and then for the upper limit, it's just the x bar plus mu. And so mu is our z score times our standard deviation over the square root of n.
Okay. I got my right thing. All right.
Okay, so help me out here. So on this last test that we had,
yeah,
The only questions I missed is I forgot to round a couple numbers.
Oh.
So otherwise I had 100%. So when we get this 498.315, what's the actual answer going to be?
There's only some that you round up on.
It always specify, yeah, if you round up to the whole number or if you...
Well, it said 3 decimal spots, so would you put 498.315?
Yeah.
The whole thing?
Yep, because it only gave 3 decimals.
Okay, so for number 5, we're going to put 498.315.
Yep, and same thing with number 6.
Well, that's going to be a little bit different. 526.
I mean, it's going to be a different number, but it only has 3 decimals.
Did you guys get 553.685?
It's so hot.
Yeah.
553.685, right?
Okay, say 5 what?
53.685.
553.865.
685.
So
Here, I'll screen share mine because mine's done.
So Adrian, are you seeing how we're getting that formula?
Yeah, I've got it. I'm
okay.
really slow when I compute things, so me doing it beforehand is going to be a very beneficial thing, believe me.
Okay, I just wanted to make sure you knew where that formula was.
Yeah, I was working it out as you guys were going, so. Okay. All right, so I had the right thing there.
Okay. Yeah, number 7 says, what would happen to the width of the confidence interval if Gina increased the sample size? So that would mean the confidence interval would decrease because you would know that you would have more confidence that would be within like a smaller amount of numbers.
Yeah,
right.
The higher the sample size, the more confident you are, so it decreases.
Right. The more specific and confident you can be. And then what would it happen to the width of the confidence interval? If she changed it to 99% confidence interval, it would increase because it was going from 95 to 99. And so then you'd be able to be more inclusive with the answers that you were including in that confidence interval.
Yeah,
okay.
Another way to look at it is because it's 99% confidence that you have 99% of the information. So you have more information.
All right. Maddie, do you want to do number 9?
Sure. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? So this is when you have the n equals z multiplied by the standard deviation all divided by the margin error. So you do the 1.96 multiplied by 400 divided by 50, and I got 246.
But then you got to square it.
Right, yeah, I always forget the square.
Okay, and then it's over 50, right? So do you do that the multiplication? So the top you have 196 times 400 first?
Yeah, so it's division multiplied by 400, then you divide it by the 50, and then you square the whole thing.
Yeah, because basically you can solve for the margin of error. Did they give us an equation on that for finding that n?
Can you see this?
Or did you just solve for n?
It's n equals z.
N equals, yeah, z multiplied by standard deviation divided by m.
All of that squared.
All that squared.
Yeah, I just had a tutor and they showed me how to do that because I didn't see the equation in our reading.
So
it was like towards the bottom of the thing.
Okay.
Okay, so let's see. So we come up with the answer for number 9.
John, this is the one you're going to round, you guys. Don't forget that.
Yeah, to the whole number, this one says.
So it should be 246. Right. That's what you said, Maddie, right?
Yeah.
Okay, that's what I thought. Making sure.
Okay, 246. Okay.
Oh, is it me again?
I could actually do it.
Okay, go ahead.
It says mean salaries of actuaries is mu of 1,000. 100,000, and the standard deviation equal to 36,730. You are interested in to know if the mean salary for women's actuaries is different from the population mean, but are not sure if it is higher or lower. You set up a hypothesis test with a level of significance of alpha equals 0.05, and your null hypothesis is it equals 100,000. Your alternate hypothesis that it's different. So you collect a simple random sample of n equals 36 women's salaries and find that the sample mean is 111,000. What is the lower limits of this 95% confidence interval? So
with the confidence levels, that's 1.96 on the Z, and that's 0.05 on the.
So
no, you don't use 0.05 at all.
Right. Yeah.
It's 11,000.
111,000.
111,000.
I did that the first time I computed it, and it was wrong. I was like, this doesn't make sense.
Minus 1.96, the standard deviation of 36,730 divided by the square root of 36.
Courtney, I didn't get the same answers for 10 and 11 as you did.
For 10 and 11?
Yeah.
So for 10, I just took 111,000 minus 2 times.
Why 2?
Because it's within. You have to do the 95% confidence, so within two standard deviations.
No. What answer did you get?
I got 98,757.
For this number 10?
10.
Okay, so the 95, for your Z, it's 1.96, not 2.
Why did I put? See, I remember reading something in the notes.
Yeah, they used 2 as being the 95%. They just kind of gave you that number, but when you do this Z, whatever, it's got the.
Oh, right. Because that's what I've been doing, but then for some reason on that one I looked it up. Oh yeah, it's because see for. Yeah, because I just did the. Okay, so they just gave you 2 because that's close to the 95%, but it's actually 1.96.
Yeah. So
okay.
You remember where they went in the assignment and they took and got the applet and drew the.
Right.
Okay.
So the answer that I got was 99,002.
99. So it would be 99,002.
Yeah.
Okay, 99,002. That's what I got too.
Okay, that's what I got.
Okay. And so then if you add it,
you get 122,998.
122,998.
Okay.
Yeah.
Okay. Sorry about that, guys.
You're good. That's what this is all for.
For real. Okay. And then it says there are 3 requirements that need to be checked when computing a confidence interval. They are all of the above.
Yeah.
Simple random, normally distributed, and a known sigma.
Yeah.
So that was kind of a short quiz today, but.
Okay, so what did you guys' answer come out to be for number 11?
Oh, 122,998.
Okay.
That's what I got.
Okay, we got 100%.
So,
Okay, so then Thursday we'll just all have our group quiz done, and we'll just walk through it.
Yeah, so just go ahead and complete the group quiz. Have it just open on your browser. and then we'll just go through the answers, make sure we're all on the same page, and when we're not, we'll figure out why. So.
Awesome.
Sorry.
Yeah. No, go.
Has anyone done the homework?
No.
Okay.
Do you have a question on that? I haven't done it, but do you have a question?
Yeah, when you guys get to number 4, like if you guys get it right, let me know, cause
Actually, I think I did do the homework. Like oh no, not the homework. I did the individual prep. So.
okay.
Okay. Well, I'll let you know.
When I get it done, if I get it right, I'll email you.
Okay, perfect. Cause I don't know, it didn't really make sense to me, so.
Okay.
Okay.
If I figure it out, we'll let you know. So,
thanks.
okay, we'll see you guys on Thursday.
All right.
Okay, bye.
Okay, I'll go ahead and post this to the.
Thanks, Sean.
Perfect.
Thanks.
Thanks, Sean.
Talk to you later.